Hi, and welcome back to another video in the topic of elements and the periodic table. This video follows on from the metal and non-metal video where we look at the reactions of metals and non-metals. So metals and non-metals actually react together quite often, but they also can react with similar chemicals to each other. So what we're going to look at is we're going to look at the reactions with oxygen, and then we're going to look at how metals and halogens react, okay? So halogens are a non-metal, so they're a typical reaction between our two types of elements. Okay, so let's start with metal and oxygen reactions. Now there's a key word in here that you guys need to know. Okay, so whenever anything reacts with oxygen, we call it an oxidation reaction. And that's because we are actually adding oxygen to whatever it is that we are reacting it with. So when we look at this, what we get is we get our metal and we add oxygen and we end up with a metal oxide. When that happens, we will always get the name of the metal and then the oxide as the name of the chemical at the end. So if I show you an example, if we have sodium and we burn sodium in oxygen, we would end up with sodium oxide. So the name comes from each part of our reaction. So if we look at this, the sodium is the sodium, and the oxygen provides the oxide. If we had magnesium, it would be magnesium plus oxygen makes magnesium oxide, and so on and so on. It will always end in oxide when it's a metal. If we look at this, there are some properties of metal oxides that you guys need to know. So if we make a group 1 or group 2 metal oxide, they are what we call bases. Okay, now a base is something that will react with an acid to neutralize it. It is also something that if we dissolve it in water will become an alkaline solution, so it'll have a pH of 8 to 14. If you can remember from when you've looked at acids and alkalis in class, you should remember that that would give us a blue purple colour if we were using universal indicator. Okay, they are normally solid white powders at room temperature, and because they've now got a non-metal bonded to them, they can't conduct electricity anymore when they're in that solid form. So that white powder cannot conduct electricity. Okay, guys, so that's metals and oxygen reacting. They will always produce our metal oxides. So let's have a look at what happens when non-metal and oxygen react. Now, again, just like I showed you before, this is an oxidation reaction because, again, we are adding oxygen to our chemical. So if we look at our reaction, what we've got is we've got our non-metal plus oxygen makes a non-metal oxide. And I'm going to run through how we do this with you. So if we had carbon and we burn it in oxygen, we would get carbon dioxide. Now the reason for this is if you look down here at this symbol, this is carbon dioxide, and carbon has a 2 after the oxygen, which tells us there are 2 oxygens. And if anyone can remember any of our names from maths and things like that, the di is a standard word that we use to represent 2. So we say it is dioxide because of that. If I was to pick another example, we might have sulfur. And if we react sulfur with oxygen, we could create sulfur monoxide. Okay. Now this would have a symbol of SO, just like we have down here. And that symbol of SO means that there's only one oxygen. And so we would give it the name mon or monoxide, meaning one. If you look at this one here, this is nitrogen trioxide, and it's trioxide because it has 3 oxygens in, so we give it the prefix tri. If I go through again, just like we did before, our properties, our non-metal oxides are acids. That means that they will react with bases to neutralize them. They will become more acidic when you dissolve them in water. And if you dissolve them in water, they produce a solution that has a pH of 1 to 6. Now, if we talk about our universal indicator, this would be a red or orange colour if we had UI in there. Okay, guys? And they, again, normally exist as solid powders. So something we were talking about in a previous video was that non-metals quite often are liquids or gases. Very few of them are solids. But if you react a non-metal with oxygen, it more often than not produces a solid powder. So we've got a different property for our non-metal oxides than we did for our actual non-metals. Okay, guys, so another example of an oxidation reaction that I want you to know about is rusting. So rusting only happens to iron, okay? It doesn't happen to any other metal. So whenever you hear someone talk about rusting, you need to automatically think iron. And what happens is the iron reacts with oxygen and water in the atmosphere and corrodes. It breaks down. Because what actually happens is, if you imagine this is the outer layer of your iron metal, the oxygen and the water react with this layer right here. And as it reacts, it turns into this orange flaky material, which then actually falls off. And as it falls off, it exposes a new layer of oxygen, which then gets reacted with, and then that falls off. And over time, what starts to happen is your piece of iron gets smaller. And as it gets smaller, its integrity is compromised. And what that actually means is it starts to break and become more brittle and fall apart. And so if you were using iron for, say, a fence or something like that, your fence would become very soft and easily broken, which is obviously not what you want from a fence. So let's have a look at what actually happens in our reaction. So we take iron 3 oxide and oxygen and water react with it. And when they react with it, they create this chemical here, which is hydrated iron oxide. Now the word hydrated just means that there's water present, okay? And so that means that the orange flakes that you see are flakes of this hydrated iron 3 oxide. It still has water in there. If you were to take water away completely, there is no rusting. So if you don't want something to rust, you need to remove either the water or the oxygen. The easiest way to do this is to paint whatever it is that you would expect to rust, which is why most fences have paint on them. Okay, guys, the next set of reactions that I wanted to show you are our metals reacting with group 7s. So this is actually a metal and non-metal reaction because group 7 elements are non-metals. So let's have a look. What we've got is we've got our group 7 elements, which are called halogens. And when they react with our metals, they produce a metal halide. So the reaction happens something like this. Your metal and your halogen are added together and they react. And when they react, they produce a metal halide. So if I was to show you an example, what I would have is I would have sodium. And if I was to react sodium with fluorine, I would end up with sodium fluoride. Okay, so when we talk about our halogens all have a similar ending name. So we have fluorine, chlorine, bromine, iodine, and astatine. They all end in -ine. When they react, that -ine turns to -ide. So we end up with astatide or fluoride, chloride, bromide, iodide. So if we look at my example over here, sodium plus fluorine makes sodium fluoride. If I was to pick another example, I could do sodium plus iodine makes sodium iodide, and so on and so on. Now, this changes the properties of our metal and our non-metal when they react. We create solid giant structures because they are what we would call a salt. And salt has this giant structure at room temperature. They can't conduct electricity if they are that solid, but as soon as you melt them or dissolve them in water, they are capable of conducting electricity again, just like a metal would be able to, except they have to be in that what we would call liquid state so that they can conduct. Otherwise, they would be just like a normal non-metal. They wouldn't be able to conduct electricity. Okay, guys, that is everything for this part of the topic. I'm going to end the video there, and I will be back soon to talk to you about Group 1 elements.